Go ahead.
Great, thanks, Sergey. So I wanted to cover sort of some advancements in text-to-image generation. Specifically, DALLE-2 was published back in March, and I thought it was pretty interesting, especially with some of their outputs. But earlier this week, I discovered that Imagen, or Imagen, I'm not sure how they pronounce it, but Google Research came out with an article last month that is competitive to them and has different benchmarks that were pretty interesting in terms of comparison between the two. So I thought I'd add it there. Brief disclaimer, I do have most of the presentation done, but I might switch over to different papers to go through some of the architecture and different things that I have not put in the presentation, but very light presentation. So if you do have questions, please feel free to stop me, ask questions, and of the like. But yeah, so for the overview, we're going to go over DALLE-2, then go over some Imagen ethical issues, and then discussion at the end. However, first, we have to talk about CLIP, or Contrastive Language Image Pre-training. CLIP is the crux of both papers, and essentially what each of DALLE-2 and Imagen are trying to take latents from. This specifically was trying to predict more or less, given an image and having a caption, whether or not they can actually predict whether or not that caption is for that image. So CLIP pre-trains an image encoder with a text encoder to predict what the images were paired with, which text of the data set. They use this behavior to turn CLIP into a zero-shot classifier, and then they turn all of the data's classes into captions for such example as a photo of a dog, much like the images taken from CLIP itself. One thing, given this model, it is a costly data set because it needs quite a lot of data, and vision models traditionally have been trained on manually labeled data sets that are really expensive to construct and only provide supervision for a limited number of predetermined visual concepts. They used the ImageNet data set within this space, but they also used privatized data sets that they've scraped themselves. These data sets go up to 650 million and are really unstructured and are pretty biased towards racial slurs, derogatory or suggestive imagery, and biased imagery as well, in different types of harsh language. Within this model, it's very narrow. When they only used ImageNet, it was good at predicting the 1,000 ImageNet categories, but it's not all that it can do right out of the box, as they put in quotes. They wish to perform other tasks, and so they tried to fine-tune the model on other data sets to get additional categories for this text-image pairing, and they were able to do so. All they could do is tell that the CLIP text encoder the names of the task's visual concepts, and then it would output a linear classifier of the CLIP's visual representation. The accuracy of these classifiers are competitive with fully supervised models, is what they claim to do. So essentially, it's a zero-shot prediction given an image or given for a specific image caption. Does that make sense? Are there any questions there?
On this figure, I might ask what the like the I1 through IN and T1 through TN represent in each of the blocks.
What is the what? Sorry, I didn't hear the end of that.
So in each of the blocks on the 5x5 grid and the 1x5 grids have either an I or a T. Could you like put that to words what those represent?
Sure. So they should be the representation or the latent representation of the image and the text for each other. And I believe they are the dot product between the two in certain sort of a latent embedding.
Okay.
Yeah. Great. So what DALLE-2 is trying to do is use what they claim or what they call unclip. And so this is the full architecture of what DALLE-2 is trying to do, where they're given instead of given an image to try to predict what the text class or the text caption is, they want to give a text classification and generate an image from it. So here they give I apologize. Here they give an example of a corgi playing a flamethrower trumpet. And so what they would do is they would use this clip objective to generate from their image encoder, but they also use a diffusion prior and an architectural prior that we'll talk about later to decode this to get additional samples that generates an array of different images that might come from this sentence. So this is definitely a high-level overview of clip. Above the dotted lines, they depict the clip train process through which they learn a joint representation space for text and images. Below the dotted line, they depict a text-to-image generation process where a clip text embedding is the first fed to an autoregressive or a diffusion prior to produce an image embedding, and then this embedding is used to condition a diffusion encoder, which produces the final image. Please note that this the clip model is frozen during training of the prior and the decoder. One thing to be noted is that they are very ambiguous and it's hard to find details of all of their encoder and decoder sizes. Specifically, OpenAI has not given good details on their sizing of networks, especially in related works, and they don't have an appendice in their paper, and anything on their website you can't find necessarily what their architecture fully is. They just give general ideas of what they might be. So I apologize if I don't have that information. They've been pretty tight-lipped about a lot of things with DALLE-2. However, we can talk about unclip. So here they have both the frozen clip encoder that is trying to get these priors ZT and ZI. What they're expectantly trying to generate here is the latency between the two and extrapolate information from them. And so the unclipped portion of this area is specifically a modified glide technique, which is also a thing OpenAI came out with earlier in the year that takes some embedding ZI given your sample to produce the probability of what X might be, given these millions and millions of samples. Specifically, how they modified glide in this context is they embed 4 extra tokens, and the tokens meaning the embeddings of specific layers, plus the glide text encoder. So they're concatenizing more information than was previously done with glide. To enable better guidance, they randomly drop some of these clip embeddings. So they have dropout within it at 10%, and then they also remove some text captioning just to give randomness to the potential output, so there's more variation within the output images. They specifically use upsampling, so they initially train on images that are 64 by 64, but then use 2 different diffusion layer upsampling techniques to get to 124 by or 1024 by 1024 images. And later I can show you in the paper that Google put out the difference between the 3 different embeddings as well. Further, OpenAI ended up cropping a 1/4 of their output images when they fed it back into the network. So what that means is they're only trying to do partial images to try to diversify their data set as well, to be able to not just train this classifier to produce the exact same image. When we talk about the priors, there's an autoregressive prior and a diffusion prior. The autoregressive prior specifically is using PCA on this latent space to use only 319 dimensions rather than the 1024 dimensions that it might actually have. It adds text as prefixes, and then there is a text transformer put on top of this as well that is a 24 block. I think the more interesting part of this would be the diffusion prior, which the authors would agree with, is that it is only using transformers, but it is encoding the text specifically of the clip embeddings plus sort of the timestamp of when it did it, and then also added noise into the latent space. So essentially, it's trying to take these crops of images as they are being upsampled, make noise to it, so it potentially might grab other types of embeddings from the text in picture state and add it to the output image. They will generate two different samples where it would only use the best one with the dot product from the latent space. To give a little example of sort of what the diffusion prior is actually trying to do, the top row is both the famous melting clocks DALL-E image. Is it DALL-E?
Yes.
Yes. It's DALL-E's image where they're trying to specifically show that they can capture both trees, the color contrast, and the clocks. One thing of note that they are very proud of is that they are also getting different times on the clocks as well. So it is not only learning the large gross objects and the color schemes that are in the images, but also different features within the objects themselves. That's the picture on the right is the OpenAI logo, which they are showing just a variety of different designs that it came out with, where it has the same color scheme in most images, but they are in different positions, but they have different schemas, all of which have some sort of 8-pointed or 6-pointed object within the picture. So great. One thing that Unclip, the decoder, does is have a interesting interpolation between some of the images that they have been put in. So variations between two of the images by interpolating their clip image embeddings when decoding with the diffusion model. So from this image, you can see they have Starry Night and two pictures of a corgi. They are using spherical interpolation between the two embeddings, ZI and ZT, between the priors. And what they are doing is modifying the circular interpolation from 0 to 1. And they're showing a couple different random seeds based off of the row value. And so what they're trying to show is that there is some kind of interpolation that you can have between them. And the way that they end up choosing even a cluster or a set of images that might work is going to be based off of human evaluation, which we will get to here in a second. But these are the two example images that they have shown, and they naturally blend between content, style, in contrast between both of the images as they're generating these interpolated images. Another thing that they were very proud to show is that they have text difference. So how do they essentially show two different text embeddings transforming a single image and a scale between the two there? And so they applied these images by interpolating between their clip image embeddings and the normalized difference between the text embeddings between the two descriptions. So for the first one, it's a photo of a cat, and then an anime drawing of a Super Saiyan cat that's an artisan. And so from what I can understand is that each of the left and right images are the true images, but they are trying to interpolate between the two that have very similar contrast, but within a varied scale. So they also perform a inversion of a very specific network called a DDIM, or I want to say differential diffusion interpretation model, which is another way of trying to find contrast in a scaling between two images that perfectly reconstructs the input image in the first column, and then they fix the denoise network across each row. And so at least they are showing the fidelity here between a Victorian house to a modern house with a similar shade of weather. I thought it was very interesting that they could do old to young. I don't know how realistic they are in terms of actually capturing an adolescent lion, but the season with the landscape is very interesting. I do think that they don't explicitly say it in the paper, but I found a Reddit post saying that this last example might be a little cherry picked, only due to the fact that they are the same forest and landscape within different months of the year. So they were kind of cheating a little bit. They talked about the importance of having their prior within the network itself. So samples using different condition signals for the same decoder are displayed here. In the first row, they pass a text caption to the decoder and pass a 0 vector for the clip embeddings. So for here, we see a group of baseball players is crowded at the mound. With just the caption, they weren't able to get as good as if they had used the text embedding prior on the latent space. So they basically pass both the text caption and the clip text embedding to the caption. Whereas in the third row, they pass the text clip embedding image embedded generated by the auto-regressive prior for the given caption, which you can argue is either better or not. The reason why I think the left area with the baseball players is not as good as potentially the hedgehog one, where the hedgehog is definitely more in focus, is because human images perform very poorly on these models at the moment. So one note to make here is that the decoder is only trained to do the text image generation task without the clip image representation only 5% of the time. And so all that means is that the image representation or the text image generation task is only decoded or trained for 5% of the total images for this evaluation. What they did was they wanted to compare to their previous model of Glide and a bunch of other different GAN models. The main ones being their previous version of DALL-E. They had Glide. I believe Make a Scene was produced earlier in February, but for the evaluation of the performance of GANs in image generation, they introduced the Fairchild Inception Distance, or the FID, which captures the similarity of generated images to real ones better than the inception score. The inception score is the estimate of the quality of a collection of synthetic images based on how well the top performing image classification model on the Inception version 3 network classifies to the 1,000 known objects within ImageNet. The score combines both the confidence of the conditional class predictions for each of the synthetic images, which is their version of quality, and the integral of the marginal probability of the predicted class, or the diversity. This has been more standard practice instead of just doing an inception score, as the inception score does not necessarily capture how the synthetic images compare to the real images. And so the goal is to develop, in developing the FID score, to evaluate the synthetic images based on the statistics of a collection of synthetic images compared to the statistics of a collection of real images from a domain target. Typically, this is extracted from one of the final layers of the inception net. So are there any questions about the evaluation? It took me a little while to really get my head around what FID is. No problem. So samples, when compared against both unclip and glide, they use the prompt, a green vase filled with red roses sitting on top of a table. And so for unclip, they fixed the latent vectors sampled from the prior and only the very beginning scaled the decoder. For both models, they fixed the diffusion noise at the seed, at the same seed for each column. And then samples from unclip improved in quality, the more realistic lighting and shadows, but not change the context as they increased the guiding scale for semantic diversity at high decoder scales. What they did further to see the fidelity of these generated images, where they performed human evaluations, which is the top rows of the right column of images, where they were checking for both photorealism, caption similarity, and diversity of images. And so they were comparing both the autoregressive prior and also the diffusion prior for how well they produced these metrics given a human evaluation. From my knowledge and digging into the text more, they only asked 1,000 people to do this evaluation. So even though the data set is very large and they produce a lot of numbers, I believe the evaluation seemed small in context of the other numbers they were using, but 1,000 seems kind of appropriate in terms of comparing between the two priors. But they did, reported figures are in the 95% confidence interval of the probability that unclipped models specified by the roads beat glide. So they sampled the hyperparameters for all the models, and they were swept to use and optimize an automated proxy for the human photolistic evaluations. Big things are the comparison when using the FFID. They use the MS COCO dataset, which is specifically the standard evaluation for GANs or GAN images nowadays, where they had 256 by 256 photos, where they were able to test the models across all of them. Unclip with the diffusion prior did perform the best, where they ended up having a zero-shot FFID with a filter, without a filter, sorry, of a 10.39. And these metrics are very much comparative. They're not necessarily an absolute, or we can't necessarily tell what it means one way or the other than the statistics that they are guiding the FFID are, you want it to be as close to zero as possible. Where this model starts to perform badly are when they need to bind, or having a lot of bind prompts together. So in the top left sort of comparison between unclip and glide, they have reconstructions from the decoder for difficult binding problems. It's the prompt was a red cube on top of a blue cube. And so they find that these reconstructions mix up objects and attributes. And so in the first two examples, the model really mixes up the color of the two objects. And in the rightmost example, the model does not reliably reconstruct the size of the two. So they go even further by testing a corgi with a party hat, or a sorry, they set a corgi wearing a green bow tie and a red party hat. And so specifically, they were trying to bind these colors to the objects. And since they believe the ordering is not captured for the combining of the two objects to the color. They have sizing issues with the glass of milk and the cookie. And then below, they really struggle with text prompts. And so the prompt at the bottom is a sign that says deep learning. And so these are their examples of not being able to perform well with that. Great. So that is essentially what DALLE-2 is. They are one of the only institutes that are trying to limit the number of people who are able to access the source code and try to use or adapt the code, or even use it in actuality. I think I signed up back in March, and I haven't heard back from OpenAI or anything of that nature. So I'm still on a wait list, but you can sign up for a wait list to see about using the application, but they're very selective and picky with that. I think the most recent one that I saw was a YouTuber that ends up talking about some of these problems, and they were able to access it probably for promotional sake. Great. So going on to Imagen. This is it's a similar architecture in the fact that they have two diffusion models training a smaller image from a text embedding, but their claim is that having the large frozen text encoder is a benefit to the amount of text or depiction or granularity between different phrases to generate these images. I'm actually going to switch over to the paper. Got it. Oop, I apologize. Great. So we have someone in the chat on the clocks. Okay. Yes. So with this, what they are claiming is that they have a larger frozen text encoder. So as you can see here, their contrast between or the contrast in length between the prompts of the text is quite large compared to the actual, or compared to DALLE-2 in that sense. And so the one that I think William posted earlier was a brain riding a rocket ship heading towards the moon. I do like that one a lot. But these are just selected samples that they have from that. The key contributions is the frozen language models on the text are surprisingly very efficient. So essentially they're using a larger UNet to train this model and then freeze the weights before trying to find the latents. And they found that even going from 6 million parameters up to 2 billion parameters, the larger the size of the net, the better. They use dynamic thresholding within the upsampling of the diffusion techniques to lever higher guidance, make more photorealistic details. And I'll show you the differences between those. They highlight differences in their proposed efficient nets. They achieve a COCO score of 7.27, which is different than the 10.39 that DALLE-2 is reporting. And then I find also interesting is they added a new benchmark called drawbench, which we will cover as well. So essentially, after not going through some of the math, what they do to not cherry pick some of the images, this paper is really trying to compare and contrast DALLE-2 versus ImageNet. And so what they did get access to the original source code, is I'm sure that they were trying to compare, but what they were doing is they were sampling from different prompts from drawbench. Drawbench specifically, we're going to jump over here, it consists of 11 different categories of approximately 200 text prompts. What they wanted to do is take the idea of paint bench, which is a different metric for GAN art specifically, where they test against different color, composition, shapes, whether or not the number of objects that they have in there, some color theory, is how well it does for text caption. And so from that, they are able, these are the different categories, and they have 200 prompts that both have misspellings, wrong order of words, and they are trying to at least set a standard for the field. Great. So with that, they are able to show at least the difference between non-cherry picked data sets from DALLE-2 and ImageNet. One thing that they did was they tried to retrain, or I know they didn't necessarily get to retrain all of these algorithms. These are all just prompted from their original papers, from what they were, what they published on their FFID. The photorealism and alignment scores, these are specifically done by comparing human evaluations on the COCO data set. They get better photorealism than DALLE-2, which was under 50%, but they still have a very high, it's still not quite as photorealistic in terms of a human evaluation. Great. One thing to note, which I kind of found interesting, is they don't really, they claim alignment and fidelity is better, but it's still not necessarily at what 100% might be, or compared to a realistic image. I'm not quite sure. Fidelity in this aspect is, does the text align with the image? And so
what is alignment? Is it human evaluated or how is it?
Yeah, so alignment in my understanding is the alignment of the, actually, I'm not sure, because I know, I apologize.
That's the image to text connection, like whether it's accurate to the text. And
But semantic alignment that could be only evaluated by a human.
oh, yeah.
Right?
Well, they
Or
talked
is it
about,
an automatic?
it said in there they got like a bunch of people to look at it.
Raters, human rater.
Yeah, but I guess I'm confused on what the difference between fidelity and alignment would be then.
On another question about the resolution, so not only they were able to increase the text prompts, but it looks like the resolution is much higher than, at least perception, than DALL-E,
Yes.
right?
One thing that's interesting, and they get more into this in the appendix, is, sorry for the scroll. That's not the one I'm looking for. Here it is. So they talk about the difference between, this is the input, the 64 by 64 image, but they were trying to differentiate between unmodified, adding different connotations of illustration and oil painting. And so the difference here, as you can see, there's higher resolution in the unmodified, but they were also able to get sort of what is going on in terms of what an oil painting might generate or what an illustration might generate. So you can sort of see the difference in the hair is kind of a good comparison. So they're saying they're doing a couple different things with their diffusion model to be able to add these types of contrasts as they scale up. These are very sparse examples, but I thought this was kind of interesting to say the least. I'm not someone who's an artist who understands necessarily the minute details or nuance between different types of paintings, so I don't know how well this is, but from just a photorealistic standpoint, they do only get 50% saying that their images are photorealistic. Another thing that is kind of interesting is they are trying to distinguish between the number of or the layering of their frozen language models. So all of these T5 small, the text model is, I believe, what they're called, but this is a very large network. I could look this up. I apologize for not having this on hand, but I think this is upwards of a billion parameters, 2 billion parameters. And it doesn't look like it's improving very much between a lot of or adding of the different parameters, even though they claim that they do. Like this figure here, the figure 4b, is kind of misleading in my opinion, because they all seem to be relatively same FFID versus their clip. So I'm not quite sure. I need to probably dig more into the appendices for why that's actually interesting or important. The other big thing that I wanted to point out about this this model, other than the really interesting pictures that they produce, which I think is great, one blog post about this talks about how the transparency within images that are produced by Imagen are significantly better than transparent images produced by DALLE-2. Here they have sort of the Fresnel effect that is happening within this. I don't know how accurate that is potentially in there, but they do have better translucency within there. Specifically, you can sort of see in the tail, but it sort of clears out a little bit as the light is shining on the object. So that's just something that many people were impressed by. I really like that image. It's pretty fun. There's the architecture that we had talked about. And was there anything else that I wanted to bring up? Oh, these are comparison images of actual prompts by the two. So you can sort of see the different clusters. Both DALLE-2 and Imagen talked about having clusters of images or images tiling a 2x2 with the prompt and asking whether or not they think the real image is better or the generated images are better. And there is a metric somewhere where I believe they're getting somewhere on 60% or less of what is actually more towards the prompt. But you can kind of do your own interpretation of the qualitative comparison of them, where this paper with Imagen has a lot more details and examples. One thing that they do also claim is that they are terrible at using any kind of human-generated images. So they've tried many times to do like President Obama holding the spear of Triton or something like that, and it performs very badly.
But we didn't hear, right? A horse riding an astronaut. So it's just didn't see anything like that in statistics, or what? Why is it getting it wrong?
Sorry, what was the question?
Well, this horse riding an astronaut. I mean, who is riding whom? The images don't capture the prompt.
Yeah, so that's another reason why it's very ambiguous, sort of what's going on, because they don't release the data at all. Because I imagine, being from Facebook, they might be taking subtitles from YouTube videos, or OpenAI might have scraped too much of the internet in terms of Facebook photos, Instagram photos, something of that nature. And so I'm not necessarily sure what is happening in terms of the data set itself.
Apparently, if you specify a horse on top, or like riding on top or on back of an astronaut, it gets better.
Weird.
It's like horse riding is a phrase that you can.
Yeah,
you're saying
it doesn't like
co-abducting with
understand
the dash
writing.
would be covering co-abducting as a one word aliens, and then I would kind of why I was also thinking who's abducting.
yeah, because yeah, even here, just like you said, since it's like kind of a backwards example where Panda should be making latte art.
That's English, I guess. Yeah, you can put a comma or whatever anywhere there.
Yeah.
On the making or panda making.
I think it was Alex who posted
I was feed to the images
earlier this week, but there's also another text to image generation paper that came out last year that does both English and Chinese. And not being a little ignorant, and I apologize, I don't know if Chinese has the same structural rules where you need to have an ordering of words, where I know in Greece you can change the words within a sentence and it can mean the exact same thing. But there might be some emphasis on one word or the other. And so I don't know if, since it's specifically trained to English, if it's suffering from some kind of context within the natural language.
How big is the data set, like in terabytes or gigabytes or whatever?
I mean, it's 650 million images to captions. And so if we say that the images are all downsized to 64 by 64, I mean, I would say probably close to terabytes, at least on a magnitude order, maybe multiple terabytes or hundreds of gigabytes. But the difference between Imagen and DALLE-2 is that DALLE-2 crops all their images, so they might have multiple crops. So that could explode very easy in terms of size of data set. Ethical issues. They're not releasing either of these, and even Google has explicitly said they're not even going to let other researchers use this yet, only because they have done like internal evaluations. They've done internal evaluations and even come up with, yeah, look, where is it? Here we go. So even though that they've done recent audit of their own data set, they've uncovered wide inappropriate use of bad imagery, racial slurs, and harmful social stereotypes. And they've assessed that it's not suitable for the public, as many of these need to become better in terms of efficacy of use, which doesn't necessarily make me feel great in terms of their pact in 2015 when they all signed data or AI efficacy laws, because now they're able to generate some of these images with potentially us in photos that are randomly generated in many different aspects, even in positional aspects, or use of very Western stereotypes in a lot of these aspects. So I don't know, it just seems odd, but maybe a step forward. They claim this is necessary because it could generate the ability to leverage art tools or be better for multimedia generation, or help Google or OpenAI make more money faster.
Yeah, I think we're probably gonna have ethical issues forever, because
How can it be avoided? I mean,
anytime they're scraping the whole internet, they're gonna have bias in their
yeah, because they even said that they tried to scrape for all of these malicious types of features within the data set, and they couldn't even get everything because they had internal auditors.
But I think, like, you know how we get how we manufacture precision tools with imprecise tools?
Yeah.
So I think here we could do something, we could train a dirty model and then prompt it with sort of ethical slogans or whatever, and generate a new data set training that is a little bit more ethical, hopefully, because we were prompting it correctly, purify it, and retrain, go through. But I mean, guarantees probably we will not have, like, we will have some tolerance, like we can reduce. But I think, yeah, it kind of seems hopeless at some, but at the other end, I think it's kind of asymptotic. We can try, like with humans, right? It's very hard to get rid of the bias.
Kind of like the GANs thing, with like generator discriminators.
Yeah, but I mean, how do you encode ethics there? It's only like evaluation here.
Well, I'm just kind of like positing that the discriminator behaves like the ethicist is. It's not bulletproof. It kind of goes back to like people always say, you know, like there's no really great definition for pornography, but you know it when you see it. That's kind of like a discriminator.
And it changes with culture change.
Right.
And how ethical is the ethicist, right? We need another control loop on top of it.
Yeah. But if we don't have any control, that'll probably end badly too. So.
Yeah. We're sort of consequentially, or coincidentally rather, MonAI and NVIDIA released a synthetic MRI data set for model training, 1,000 images, human MRI and everything. And so looking at, we think of ourselves as the expert in images and text, and we're the best thing that we know, right, for semantic analysis of that kind of data. And yet we're having huge trouble, even like here, evaluating the quality and alignment. And now imagine how many people will be able to evaluate the quality and realism of MRIs when the models generating them in thousands, like, oh, hey, here are thousands MRIs. So it's an actual thing. I'm not making it. They released it, but it's very hard to say, like, are they even anatomically correct? I know Satra Ghosh, my collaborator, his team is working on trying to generate GAN-like architectures to generate at least anatomically sensible MRIs.
Yeah.
And they, to me, like on the first glance, they look quite MRI-ish. I mean, the architecture, the cerebellum is where it's supposed to be, and corpus callosum is there, and everything. But no, like it's like they can spot it's not real. So it's even the like, well, they have hours of training.
I think in some of this stuff also, like because they can cherry pick the images. It's really like what they put in the papers versus what you get as you work with it. You'll notice a big difference. I noticed that in like image painting with UNet. I know UNet architectures have improved significantly, but I noticed in their failure cases. Do you mind going to that area with like the corgi and the bow tie and the heads?
Yes.
There's like some kind of like characteristic UNet failures in my opinion there.
Can you point them?
Yeah. It's the bow tie.
The bow tie thing was in the PowerPoint, I think.
Oh, was it? Okay.
It was in this paper. Okay.
Yeah, there was a PowerPoint, yeah, but it's, if you can zoom on it because it was so small. And what's up with the clock? I don't know, Kevin had a comment about the clock, the numbers. Can you zoom in on the clock while you're scrolling through?
Yeah, the fine
Yes.
details, the fine details UNet used to really mess up in painting a lot.
Can you zoom in on the numbers? I just don't see them. 1, 2, 3, 7, no, 4, no?
Yeah, there's some errors that
Are there?
probably like
See, there's like a
like
9 on the
these
right.
things are just they're kind of blurred. They're not.
Yeah. Oh, there is a 2, yeah.
It's kind of like they had like a collapse between like somewhere in the space between like one.
I think they were more pointing out that there were different hand positions, but also there are multiple more hands in them. So
there is
it might be an
8 and
overclaim.
13 in other places. But I would be surprised because you're pointing out the translucency there, It's like linear optics, right? All of the computation of all of the rays. If it learned physics from just observing, that would be kind of interesting. Well, but apparently.
Oh, yeah. It's
Corgi bow tie. If you guys wanted the corgi bow tie.
It's right there.
Yeah,
Yes,
there we
yeah.
There we go.
What's so?
I
Can you
don't-
zoom in just on
I don't
that?
know if I can see if I just, I don't see the phone right now. Maybe it's not there. I just imagined it. Could you scroll up a little bit?
Yeah.
I think it was on this guy, like near his eye. I'd often see it on like the eyes, there's kind of like a blur between the boundary regions a little bit.
No,
It's not
you're
that bad.
you're too picky.
And it is a little bit fatter on one side of the face than the other, but
Mhm. Oh, like symmetry is not.
yeah, it definitely messes up some symmetry in some situations, but I wondered when I was doing like working within painting and unit, I kind of wondered if how much particle relationships is captured by a unit, like if it like how does it do any of this really? Like I definitely couldn't tell you.
Well, the eyes are the same color. That's amazing, right?
Yeah, that's probably pretty standard.
Yeah,
Well,
because even
Not
the young one has different colors in the eyes, and they're kind of diffusing between the two.
A lot of the face generation models that you see on the internet, that's one of the clues that they're fake, is different eye colors along with artifacts and hair. So it is actually kind of impressive that they're able to match eye color.
Well, this whole part relationship, that's kind of like the bilateral symmetry.
It's kind of like, it's like the information from one side of the image doesn't affect the generation on the other side of the images. In my mind, it's like something to do with like receptive field between, I don't know.
So one thing that I didn't understand, so in the original clip model, from what I understand, when they do clip, your matrix, your outer product matrix is however many samples you have by however many samples. Because it's trying to match it with the exact prompt image. But there's no way to do that with 600 million samples. And I know you said that they were kind of vague about it, but is there any idea as to how they actually accomplished that?
I don't. I would have to go look into the paper. I was trying to get pretty thick into these two, so I apologize for not getting to that one.
No, I mean, they probably obfuscate a lot of this on purpose. And it's also possible that they just threw every single scrap of hardware that they could purchase with billions of dollars.
Yeah, I mean, Elon Musk has thrown a lot of money at OpenAI anyway, and Google, of course, has too much compute power anyway.
Yeah, the reason I asked about the dataset size question is it kind of reminds me of Sergey. I don't remember what paper we were talking about, but it was like I was able to do some fairly impressive. I think it was like GPT-3 or something like this. I was able to almost code in some, but it like the way it's able to like kind of fool you is just the massive size of the data set that it's scraped from the internet. It's basically
terabytes, I think.
it's kind of like searching Stack Overflow for like the closest thing when it generates code or something. I mean, which is what a developer would do, but it's like it doesn't necessarily have to bake into its system like any sort of structure of language. It just has to do like a closest match.
Chinese room, that's what the concept you're looking for.
And there's no guarantee that we are as highly structured as we imagine
Yeah,
ourselves.
I'm sure we are Chinese rooms as well.
Yeah.
To a large extent. It's pattern matching. But you had an intriguing phrase in your abstract, TJ, in the reading group channel when you announced that talk. You said you had some ideas, or you wanted to discuss some ideas, how all of that might be relevant to what we're doing with computational neuroscience and things.
Yeah, I mean, you sort of brought it up already, but it was just, can we reasonably generate any kind of images that would be example for a toy data set, or create use essentially human connectome project and go from 1,000 samples to 100,000 samples? Do we even try that? Is that even feasible? And I think in terms of the ethics and stuff, we've talked about this already. But we would need to have enough evaluators for this type of labeling, or even have, I just don't think the data sets are there to even attempt this, and they're so small compared to what these two large institutions are doing anyway, many orders of magnitude larger. But I don't know if having the finer grained details might actually be better or worse, because there's a lot more detail within the neuroscience data sets, rather than some of these images that are just like, it's a corgi or it's the face of a house, where there's a lot more detail in terms of the structure, like you were saying your collaborator does. So I'm interested in that as a discussion, but I know that we're sort of running out of time-ish. But it'd be on the same lines that we were talking about 5-10 minutes ago.
Yeah, we're out of time, but it's good to, to add, to contribute to the discussion. So,
because I've seen images where there are like ablation or at least crops of images taken out of different types of neuroscience images, where they end up being able to use GANs of some sort. And this was 4 years ago, so it's probably changed since then. But trying to fill in those blank spots, especially when imaging can't necessarily capture everything, and there's some kind of error that creates a type of misalignment or some kind of missing part of the data for fMRI. So I don't know to what extent that research has been continued, or what is out there for filling in missing data, but this might be a type of method to look into, but I'm not sure.
Yeah, but one good thing for us in this research is multimodal combinations, because when you don't have enough data just to get the statistics, if we enable, I think, some inputs from other experts, or at least, like when somebody draws on the whiteboard, here's how the brain looks, or like shows you cartoons of the brain, and then shows you different, like a real, human brain when they open up cadavers, or MRI, even like you can transfer some knowledge by operating and teaching a student on cartoons, and then kind of getting them up to speed with real statistics of the images, instead of trying to train a model fully just on MRI images, which are hard to get. So here they combining text and images and generation, but maybe we can learn from this how to combine different various signal and train a model that will be better anatomist, right?
Yeah.
From various sources, just verbal descriptions as well. Like this part of the brain is always smaller than that part of the brain, and like information like that. If we can train,
we would have to digitize every anatomy book in the last 100 years, but that could be kind of fun.
Well, if it can read that book, yeah, and learn from it, then that's fine, right? But yeah,
I think that's part of the mission of Google Books, is to like scan everything like that.
they scanned the Library of Congress, but they stopped 2012 or something. Like, I would love to see the n-gram statistic. Happen to support vector machines, right? They kind of go down there. Are they at 0 now? That mentioning all these trends and stuff. That was interesting. But anyways, thanks a lot. That was a fantastic talk, very interesting, and the images are impressive, of course. Next week is Human Brain Mapping Conference. Many people will be out and out of sync, so we won't meet. But the week after, let's meet and have a session with a slide from each one whatever you've seen at the HBM, virtual or in person, and who's going from the room. No one, yeah, just so it's not too many people, exactly. Okay, thanks a lot, everyone. Bye-bye.
Thanks, everyone.